paper for 10th class for icse board. Okay, in this video I am going to discuss section B of the same paper. So let's start. See, section B again of 40 marks. From here we have to attempt any 4 questions. Okay, so question number 4, first part of question number 4. A ray of light enters a glass block from air and come out from the opposite surface. If the angle of refraction at the first surface is not the same as the angle of incidence at the second surface. Okay, so here it is mentioned that angle of refraction at first surface and angle of incidence at second surface are not equal, and it is a glass block. So if we see the glass block, okay, if it would be of this type as we have studied, okay, then this is the incident ray. This here it is refracting at the first surface. After refraction it moves in this direction, and from here it comes out. So if these two faces are parallel to each other, then these two angles will be equal. This is the angle of refraction at the first surface, this one is the angle of incidence at the second surface. Okay, but here it is mentioned that this angle and this angle are not equal. Angle of refraction at first surface and angle of incidence at second surface are not equal. So it means that these are not parallel. So it will be of this type. Okay, this is the angle of incident ray. Okay, this is refracted ray. This is the angle of refraction at first surface. This one is the angle of incidence at second surface, and this is the emergent ray. So in this case, R1 and I2, that is the angle of refraction at first surface and angle of incidence at second surface, will not be equal. Okay, now so diagram will be of this type. Now here in first part they are asking what is the product of ratio of sin I upon sin R at first surface and at the second surface. So let's see it again. See, at first surface, that is at AB, light ray is moving from air to glass. So refractive index of glass with respect to air is equals to sin I1 upon sin R1, angle of sin of angle of incidence upon sin of angle of refraction. Then at this surface, second surface at CD, light is moving from glass to air. So from here we will get the angle of refraction of air with respect to glass. It will be angle of incidence at the second surface, that is sin of I2 upon sin of R2. Okay. Now sin of I1 upon sin of R1 into sin of I2 upon sin of R2 equals to A mu G into G mu A. But G mu A is equals to 1 upon A mu G by the principle of reversibility. So these will get cancelled, it will be equal to 1. Okay, so it doesn't depends upon these two faces of this glass. This product will always be equal to 1. So for this first part answer is 1. Now in second part, state whether the opposite surfaces are parallel or not parallel. Okay, and in third they are asking how did you reach the conclusion in B above. So we can see that as angle of faces are not parallel, and AB and CD are not parallel, otherwise angle of refraction at first surface should be equal to angle of incidence at second surface, but they are not given to be equal. What does it mean? It means that AB and CD are not parallel. Okay, so they are not parallel, and why they are not parallel? Because angle of refraction at first surface is not equal to angle of incidence at second surface. Okay, now second part of question number 4. A type of glass block has a refractive index of 1.8. Refractive index they have given. Calculate the speed of light in this glass. Speed of light we have to calculate. Speed of light in air is given to be 3 into 10 to the power 8 meter per second. Okay. So again using the formula of refractive index, A mu g is given to us 1.8. Speed of light in air is given 3 into 10 to the power 8 meter per second. So A mu g equals to speed of light in air upon speed of light in glass. That is 1.8 equals to 3 into 10 to the power 8 upon V. So from here we get V equals to 1.67 into 10 to the power 8 meter per second. Okay. Then in next part they are asking if the width of this block is doubled, then what will be the speed of light in the block? If the width is double, then what will be the speed of light in block? So speed of light in block doesn't depend upon the width of the block. Okay. It depends upon the density of the medium through which it is passing. It doesn't depend upon the width of the block. So speed of the light will remain same. Okay. Third part of this question number 4a, name the electromagnetic radiation used to detect fake currency. So this depends upon the properties of electromagnetic radiations. Okay. So the radiation which is used to detect the fake currency is ultraviolet radiation. Okay. Then in second part we have redraw the diagram given below. This diagram we have to redraw and complete the path of the light ray AB through the glass prism till it emerges out of the prism. Critical angle of the glass is 42 degree. This is given to us. So this type of figure we will get when it enters from this surface at B when it strike. Okay. Here it is perpendicular to this surface, so it will not get reflected, move as it is. Okay. So this angle is not of 90 degree. This angle they have given, it is of 30 degree, and this is of 90 degree. So by angle sum property of triangle, this comes to be 60 degree. Now consider this triangle. In this triangle it is 60, this one is 90, then this one will be 30. Now this is normal. Okay. So this angle, that is angle of incidence at this surface, will be 90 minus 30, that is 60. And this angle of incidence 60 is greater than 42, that is angle of incidence is greater than critical angle. So what will happen at C, when it strike at C, here total internal refraction will take place and it will move into the same medium following the laws of reflection. Okay. So this angle will be of 60 degree, angle of reflection. Sorry. Now this one will be of 30 degree. So when it strike at this surface at point D, now in this triangle, these two angles are of 30 degree each. So this will be of 120 degree. Okay. So this is normal. Okay. So this angle, that is angle of incidence at this surface, will be 120 minus 90, that is 30 degree. And this time 30 is lesser than the critical angle, that is 42 degree. So what will happen? Light will move out from this surface following the laws of refraction. Okay, at this surface refraction will take place. So this type of diagram will be there for this question. Now next is question number 5. Here we have an object placed in front of a convex lens forms an image of same size on a screen. Moving the object 12 cm closer to the lens results in the formation of a real image which is 3 times the size of the object. So what we are having in this one, see, as in the first case we are getting the image of the same size, it means that object is at 2f and screen is also at 2f. Now what they have done, object is moved by 12 centimeter towards the lens. So now the distance of object from the lens is 2f minus 12. Screen remain at the same place. So v is 2f. So from here what we are having, and magnification they have given 3. So m equals to v upon u. So magnification is 3. Okay. V is 2f and u, since we have to, u is measured in this direction towards the left hand side, so it will be negative. So 3 equals to 2f upon minus 2f minus 12. So minus 6f plus 36 equals to 2f. On solving this we will get f equals to 4.5. So focal length of this lens is 4.5. Okay. Now second part. Here atmospheric temperature after a hailstorm is greater than the temperature during the hailstorm. Okay, obviously it is false. After the hailstorm temperature drops down. Okay, so this one is false. Second part, which thermal physical quantity of a frying pan changes by making its base heavier? So when we make the base of the frying pan heavier, then it is, we do this to increase its heat capacity. So by increasing the heat capacity, what will happen? It will get heated slowly, and heat provided it by for cooking will be in a slow rate, so that cooking can take place slowly. Okay. Now third one, state the principle of calorimetry. So same means from the book itself, heat lost by the hot body equals to heat gained by the cold body. Principle of calorimetry. Now third part, the given graph represents the cooling curve of a liquid. This graph is given to us. So graph goes down PQ, then QR is a horizontal line, then R2S. So QR is showing the change of phase. So liquid when it is being cooled, P2Q it is liquid, Q2R phase is changing from liquid to solid, then R2S again getting cooled. Okay. So now what they are asking in first part is state the freezing temperature of the liquid. So freezing temperature at D it will get start freezing, है ना? So 20 degree. So freezing temperature is 20 degree centigrade. Then name the phase change happening in the region QR. So in QR, phase changes from liquid to solid. It is changing from liquid to solid. Then next one is, in which state solid or liquid does the above substance liberate heat at a faster rate? ठीक है. So now let us find out the rate of liberation of heat. So here change in temperature is from 0 to 20 and time is from 50 to 20. Sorry, temperature is from 50 to 20, time is 0 to 20. So for liquid we have change in temperature upon change in time, that is 50 minus 20 upon 20 minus 0, 30 upon 20. So 1.5 degrees centigrade per second. Then for solid state what we are having, temperature is changes from 20 to 0 and time is 30 to 35. So for solid temperature changes 20 minus 0 and change in time is 35 minus 30. So 20 upon 5, that is 4 degrees centigrade per second. So rate of change of temperature for solid is more than for liquid, है ना? So in case of it is more in solid. Now question number 6. Here the diagram shows a wheel with a handle. Two forces F1 and F2 of equal magnitudes are acting on the handle as shown in figure, है ना? So which force produce negative moment? So F2 is producing anti-clockwise moment and F1 is producing clockwise moment, and we know that clockwise moment is negative. So moment produced by F1 is negative. Then is the wheel in equilibrium? Yes or no? So moment due to, see, F1 and F2 both forces are equal. Moment due to F1 is F1 into R, perpendicular distance between force and the uh, axis of rotation, application of force, F1 into R is the moment due to F1, and for F2 moment is F2 into R. So moment is same in both the cases. Okay, moment is anti-clockwise moment. We are having F1 into R, and clockwise moment, sorry, clockwise moment is F1 into R, anti-clockwise moment is F2 into R. But F1 and F2 are same, so F1 into R equals to F2 into R. So what does it mean? Wheel is in equilibrium. Now justify your answer. So because moment is same, anti-clockwise moment and clockwise moment are equal, so body is in equilibrium. Now for second part, we have name the unit of work done used in subatomic scale. So it is electrovolt, EV. Then B part 2, which class of lever does a pair of scissors belong? So in scissor, fulcrum is in between load and effort, so it belongs to class 1. Then a stone is tied to a string and displaced from A to B by application of constant force F in 3 different ways as shown in the diagram below. Arrange the 3 cases in ascending order of the work done by the force. See, in first case, okay, force is directed towards the center and it is moving in on a circular path. So this force is providing the centripetal force, and motion is tangential, so this force is perpendicular to the direction of motion. So work done due to this force is 0. Now in this case, force is along the direction of motion of this stone. Okay, so here work done is equals to force into displacement, that is AB. And in third case, we are having force at an angle of theta with the displacement. So work done is equals to F into D cos theta. Okay, so minimum work is done in this case 0 due to the force F. Then here on second place, this will be there, work done in the case third, that is FD cos theta. And highest work, maximum work is done in the case 2, in which force is in the direction of displacement, that is FD. Okay, so work done in case 1 is least, then in case 3, and maximum work is done in case 2. Now third part, a ball of mass 20 gram falls from a height of 45 meter. It rebounds from the ground to a height of 40 meter. Calculate first initial potential energy. Okay, direct formula based mgh. So m is 20 gram, change it into kilogram, 20 upon 1000. Then g already they have given 10, height is 45 meter. So in first part, that is initial potential energy is 9 joule. Now in second part, speed of the ball at which it hits the ground. So when it hits the ground, its kinetic energy is equals to it has maximum kinetic energy, and that is equals to maximum potential energy, that is half mv square equals to mgh. So from here we get V equals to under root 2GH, and on solving this we will get V equals to 30 meter per second. In third part, they are asking loss in kinetic energy on striking the ground. Okay, so loss in kinetic energy is equals to loss in potential energy. Initial potential energy was 9 joule, and after striking it rebounds to the height of 40 meters. So now again find out the potential energy by mgh. So we'll get it as 8 joule. This time height is 40 meter. So loss in kinetic energy equals to loss in potential energy, that is 9 minus 8, that is 1 joule. Now question number 7, first part. To lift a load of 30 kgf, Suhas uses a single fixed pulley while Radha uses a single movable pulley. The displacement of effort in both the cases are equal. In an ideal situation, calculate the ratio of the effort in the two cases. Okay, so in single fixed pulley, okay, this is the diagram of the single fixed pulley. Load, effort, and load is L equals to T equals to E, so E equals to L. In case of single fixed pulley, effort is equals to load, and in case of single movable pulley, L equals to 2T, E equals to T, तो E equals to L upon 2. ठीक है, तो effort in both the cases. In first case, effort is equal to equal to load, and in second case, effort is equals to half of the load. So effort in first case is more than effort in second case. Okay, effort in first case is more than effort in second case. So in first case, load they have given 30 kgf. So effort in first case, when we are having the single fixed pulley, effort is equals to load, that is 30 kgf, and when we are having single movable pulley, effort equals to L upon 2, that is 15 kgf. Now the potential energy gained by the loads in the two cases. Okay, so in velocity ratio, in case of single fixed pulley will be 1, and in case of single movable pulley, velocity ratio is 2. Okay, so displacement of load upon x. Okay, let the displacement of effort be x. Displacement of effort will remain same in both the cases. dl upon x equals to 1, and in case of single movable pulley, dl upon x equals to 2. So from first one we get dl equals to x, and in single movable pulley dl equals to 2x. Means distance travelled in single movable pulley is twice of the distance travelled in single fixed pulley. So potential difference gained in single movable pulley is twice of the potential and energy. Potential energy gained by a single movable pulley is equals to twice of potential energy of the single fixed pulley. Then efficiencies in two cases. So efficiency, already it is mentioned here that in an ideal situation, the efficiency is 1 in both the cases. Now second part. First, one end of a plastic foot ruler is held tightly at the edge of the table and the other end is plugged. Name the vibration produced in the ruler. Obviously damped vibration. Okay, it will be damped vibration. Then B, now the ruler is pushed inside partially and plugged again from its free end. State with a reason whether the frequency of vibration increases or decreases. So frequency will increase. Why? Because frequency is inversely proportional to the length of the vibrating body. So F equals to 1 upon length. Okay, so when we decrease the length, when we are pushing that ruler inside, it means we are decreasing its length. So length is decreased, it means frequency will increase. The frequency of vibration will get increased. Now third part. Here they have given two persons A and B are standing in front of a cliff in the same line 1 centimeter apart as shown in figure. Okay, as shown in diagram. Person B fires the gun and hears the echo in 3 seconds. Then the person is standing in front of the person B fires the gun. Okay. So the distance of the person B from the cliff. So he hear the echo in 3 seconds. Okay, so let the distance of the cliff and person B is D. Time taken is 3 seconds. Speed is given to be 340. Okay. So we have 2D equals to time into speed. So 2D equals to 3 into 340. So from here we get D equals to 510 meter. So distance between person B and the cliff is 510 meter. Distance between the cliff and the person B is 510 meter. In second part, the minimum time in which B hear the gunshot fired by A. So minimum time will be when he hear the sound directly. Okay, that will take minimum time to reach to B. So distance traveled by the sound is 170 meter and speed is 340. So minimum time equals to distance upon speed, that is 0.5 second. Now, eighth one, bulb A rated 160 watt 40 volt and bulb B rated 40 watt 40 volt are connected as shown in the diagram. Okay. Now calculate the ratio of V1 to V2, potential at A to potential at B. They are connected in series, so current will remain same. Potential will be different in both the cases. Total potential is also given to us, that is 40 volt. So what we are having here, bulb A, for bulb A power is 160 watt and potential is 40 volt. So using the formula P equals to V square upon R, R equals to V square upon P, so it is 10 ohm for bulb A. Then for bulb B, power is 40 watt, potential is 40 volt. Okay, so P equals to V square upon R2. So R2, that is resistance of the bulb B, is 40 ohm. Now in series circuit, current remains same, IA equals to IB, and current is equals to potential upon resistance, so VA upon RA equals to VB upon RB. So that is VA upon VB equals to 10 upon 40, so 1:4. So potential at A ratio potential at B, and V1 ratio V2 is 1:4. Now B, if the bulb A fuses, the current in the circuit remains the same. Stay true or false. So if bulb A fuses, then bulb B will also stop glowing. It will not glow at all because both are connected in series. So there will be no current in the circuit. Okay, so it is false. Now second part, the reverse side of the 3-pin plug with incorrect connection of wire is shown in the diagram below. So what we have to do? Identify the fault in the above connection. So we have what we are having here. See, it is plug is in reverse order, and when we put the plug in such a way that pins are towards us, okay, then what we are having, left is live and this one will be neutral. Okay, so this point will be live, this point is neutral, and above one will be the earth. Now see, neutral is blue, this is correct, but live is green wire and earth is red wire. So these wires are being interchanged. ठीक है ना? So that is the fault here. Red should be live wire and green should be earth wire. Then mention a risk factor involved if the user operates the appliances without correcting it. So if user uses the operate the appliance without correcting it, then what will happen? This earth will get connected to the live and earth is being connected to the body of the appliances. So body of the appliances direct come in contact with the live wire. Okay, and what will happen? Current will be there in the body of the appliance. So when we touch it, we will get a shock. Then, will the appliance function in the present situation? Yes or no? Okay, so it won't apply in the present. It will not operate. Appliance will not work in this case because live is not connected to the main. ठीक है ना? Main is connected with the earth. Live is still not receiving the current. So this appliance, current will be there in the body of the appliance, but appliance will not function at all. So answer is no. Now in third part, in the combination of resistors shown below, calculate the resistance across AB when the switch S is open. So when switch S is open, then circuit is equivalent to this type, है ना? These two are in series, these two are in series, and these two arms are in parallel. So resistance of this arm is 12 plus 6, that is 18. For this one it is 6 plus 12, again 18. And total resistance, equivalent resistance is 1 upon R equals to 1 upon R1 plus 1 upon R2, that is 1 upon 9. So 9 ohm will be the resistance. Now in second part, when the switch S is closed, ठीक है, when switch S is closed, then the equivalent circuit will be of this type. ठीक है. Now these two are in parallel, these two are in parallel, and these two are in series. So first of all, calculate the resistance for this part. So 1 upon R1 equals to 1 upon 12 plus 1 upon 6, that is 4 ohm. For this part again 4 ohm, and total resistance is 4 plus 4, that is 8 ohm. ठीक है. Now ninth one, question number 9. We have question number 9. We have an electric iron rated 1100 watt, an electric iron rated 1100 watt 220 volt is operated for 5 hours. Calculate minimum rating of the fuse wire. Okay, so we have to find out the current limit for this one. Okay, so for this we have to make use of the formula P equals to, P is given to us, V is given to us. So make the formula P equals to VI. So I equals to P upon V. From here we get I equals to 5 ampere. So minimum rating of this fuse should be 5 ampere. Energy consumed in kilowatt hour. So energy equals to power they have given in watt. So for kilowatt divided by 1000, so 1100 upon 1000 into 5. So 5.5 kilowatt hour. Now cost of energy consumed if the rate is rupees 10 per unit. So cost equals to total unit into rate, that is 55 rupees. Now in second part, when the magnet as shown in the diagram is moved towards the coil at a speed of 5 meter per second, the galvanometer shows a certain deflection to the right. How will the direction and magnitude of deflection change when the coil also move with a speed of 5 meter per second? Okay, how it is moving now? In first part, in the direction of the motion of the magnet. Okay, magnet is moving towards the left and this is also moving towards the left. Okay, na? Both are in the same direction. Then what will happen? Then it will not show any deflection. Okay, current will not induce because change in magnetic flux is not there. Both are moving in the same direction. It means magnetic flux is not changing, so current will not induce, so galvanometer will not show any deflection. When it is moving in opposite direction of the motion of the magnet, okay, so when it is moving in the opposite direction, then what will happen? Then a galvanometer, okay, here the at this end north will be there. Okay, direction of current will be of this type from here. Okay, direction of current will be this one. This will be north, this one will be south, so this will be the direction of current. So deflection will be towards the right, deflection of galvanometer towards the right. Okay, ठीक है. Now magnitude of deflection will be increased. Magnitude of deflection will increase because rate of change of magnetic flux is increased. ठीक है, when both will move, ठीक है, when both will move, then rate of change of flux will get changed. So what will happen? Magnitude of deflection will increase, more current will be induced. Now in third part, first, which element is used in lining of special apron worn by workers in nuclear power plants? Lead lining is being used. Why is this element preferred? Because it absorbs the gamma radiations. Then B1, 24 Na11 emit a nuclear radiation which does not alter the mass number but is deflected by the magnetic field. So two rays are there which do not alter the mass number. Okay, gamma rays and beta rays. But gamma rays doesn't get deflected by the magnetic field. So the answer is beta ray. Name the type of nuclear radiation emitted by this, that is beta radiation. Now write the equation of this radioactive decay. So 24 Na11 minus 0 beta minus 1 equals to 24x12. This will form. Okay, so this was the discussion for the 10th class physics paper. Okay, so thanks for watching this video.